Welcome to this explainer. We're going to get you kitted out with the fundamental tools you absolutely have to have ready for your GCSE Computer Science programming exam.
So what we're going to do is break down all the key stuff from Section 2.2 of the OCR J277 specification. You can think of this as us opening up the Ultimate Programmer's Toolkit and looking at every single essential item one by one.
So here's the game plan. We'll kick things off with the basic materials, the stuff you built with. Then we'll jump into the language of logic that lets your programs make decisions. After that, we'll see how to control your program's path, organize all your data, and finally, we'll get into the real power tools for building clean, reusable code.
First up, the core ingredients. Look, at the heart of any program you write is data. But to actually use that data, you need places to put it, containers to hold it. And that's exactly where we're going to start.
Okay, the first two tools out of the box are variables and constants. Just think of them as named containers for your data. The real skill here, and what you'll be tested on, is knowing when to use each one. You've got to know that if a value, like a game score, is going to change, you need a variable. But if it's fixed, like pi or the VAT rate, you use a constant. Simple as that. It makes your code way clearer and stops silly errors.
Right. These are the 5 big ones you have to know. Picking the right data type is a super important skill. Is your data a whole number? That's an integer. Does it have a decimal point? Then it's a real. Is it a simple yes or no, a true or false? That's a Boolean. Or is it just one single letter, a character, or a bunch of them, a string? Getting this choice right is a huge deal. It affects everything from how your program runs to how much memory it chews up.
All right, so now we've got our data tucked away in these containers. What's next? Well, we need tools to actually do stuff with it, and that is the job of operators. Think of operators as the verbs of your code. They're the doing words. You'll be using these all the time to do calculations, compare things, and combine conditions to make your program smart.
Here we go, the arithmetic operators. Now, you'll know most of these from maths class, for sure, but the ones you really need to pay attention to for your exam are mod and div. Mod gives you the remainder from a division, and div gives you just the whole number part. Trust me, they are incredibly useful for solving all sorts of problems, like figuring out if a number is even or odd.
Now these comparison operators are the absolute heart of decision-making in your code. They always give you back a Boolean value, a true or a false, and that's what lets your program decide which way to go. And hey, see that double equals sign for equal to? That's a classic trip-up. So easy to type just one and get an error, so watch out for that.
And rounding out our operator toolkit, we have the Boolean operators. These are your logic power tools. They let you build really complex questions like, is the player's health below 20 and do they have a potion? This is how you create some really sophisticated logic.
Right. We've got our ingredients, we've got our tools to mix them, but a program isn't just a jumble of instructions, is it? You need to be the director, telling the program the exact order to run things in. This is called program flow, and it's absolutely fundamental.
And here's the crazy part. Every algorithm, and I mean every single one, from a simple calculator to a massive video game, is built from just these 3 things. Sequence is the default, one line after another. Selection, that's your if statements, creates different paths. And iteration, well, that's loops for repeating stuff without writing it out 100 times.
Now, when it comes to repeating things, you've got 2 main types of loop. A for loop is your go-to when you know exactly how many times you need to repeat something. It's like saying, I'm going to do this exactly 10 times. A while loop is more flexible. It's like saying, I'm going to keep doing this until the user finally enters the right password.
This right here, this is a skill you will almost certainly have to show in your exam. Being able to trace the flow of a for loop, step by step, watching that counter start, checking the condition, running the code, and then increasing. You've got to get comfortable with this process.
All right, up to now, we've been dealing with one piece of data at a time, like one score or one name. But what happens when you've got a whole list of them? Let's look at the tools for handling big collections of data.
An array is basically like a row of numbered boxes, perfect for storing a list of related things, like all the high scores in a game. The key things to remember are that everything in it has to be the same data type. And the super important thing, that numbering, the index, it almost always starts from 0, not 1. That catches a lot of people out.
Strings are really just a special kind of array, an array of characters, and you need to know how to mess with them.
The two big techniques are concatenation, which is literally just sticking strings together with a plus sign, and slicing, which is grabbing a chunk of that string. Super useful for things like validating an email address or pulling out a username.
Now, this next one, SQL, might feel a bit out of place with the rest, but it's in the spec, so we need to know it. It's all about grabbing data from a database, and you only really need to remember 3 keywords. You select the columns you want from the table they're in where they meet some condition. So you might say, select score from high scores where player equals Amy. It's basically just asking a question in a very structured way.
Okay, last section. Look, when your programs start getting more complex, the last thing you want is to be copying and pasting the same chunks of code all over the place. It's messy, right? To write good structured code, you need to build reusable blocks. You've got 2 types of these subprograms, procedures and functions. They both wrap up a block of code to do a specific job. But here's the absolute key difference, and you have to remember this. A function always gives something back. It returns a single value. A procedure just does its thing and that's it. It doesn't hand anything back to the main program.
And this really gets to the heart of why we do this. It's not just to be tidy. It's about breaking down huge, scary problems into small, bite-sized pieces you can actually solve. It makes your code so much easier to read, to test, and, when things go wrong, to fix.
And that's a wrap. That was a whirlwind tour of your entire programmer's toolkit, covering all those fundamental techniques from Section 2.2 of the spec, from variables and data types all the way up to subprograms and SQL.
So, the final and most important question is for you. Be honest with yourself. Looking back at all these tools we've just unboxed, which one feels a bit rusty? Is it loops, maybe messing with strings, or is it that Boolean logic? Whatever it is, find that weak spot and hammer it with practice questions. That's how you'll smash it. Good luck.